Okay, welcome. Our mission today, well, it's a deep dive into this major weather pattern that's setting up across Europe. We're talking late October through mid-November 2025. The sources, they're pretty clear. This looks like an anomalously wet and mild period, and it seems to be driven by two big factors converging. So we're really looking at a prolonged, pretty severe flood risk here, and we need to understand, what's driving it.
Yeah, and what's striking is the agreement. You look at the major models, ECMWF, the UK Met Office, Met Arian, they're all showing really high confidence. It looks locked in. We are facing a significantly elevated widespread flood risk. Some vulnerable spots could see precipitation totals in the, well, hundreds of millimeters.
Hundreds, that sounds like a lot.
It is. Think maybe 2, even 3 months of typical autumn rain falling in less than 2 weeks. So yeah, this is a really serious forecast we need to unpack.
Okay, right. Let's trace this back. It didn't just appear out of nowhere, did it? Storm Benjamin around October 23rd seems key. That storm, it acted as a kind of dynamic catalyst, is that right? It sort of violently shook up the jet stream.
That's exactly right. And that initial violence, it actually allowed the atmosphere to settle into a very stable setup. We call it a classic dipole weather pattern. So imagine this deep, low-pressure area, a trough, just sitting over the North Atlantic. And at the same time, you get a blocking high-pressure system nearby.
Okay.
That difference, that gradient, it sets up this powerful, very stable southwesterly flow. Think of it like an atmospheric conveyor belt. And it just continuously funnels warm, moist air onto the continent. The stability is crucial here. It means the rain keeps hitting the same areas day after day. That really ramps up the flood threat.
Right, so the track is locked in, it's stable, but what's making the air on that conveyor belt so exceptionally wet this time?
Good question. That's where the second piece comes in. The thermodynamic amplifier, you could call it. And it's powered by the ocean. An oceanic engine. We're seeing these anomalously warm sea surface temperatures, or SSTs, especially the Mediterranean. It's running like 1.5 degrees C, maybe up to a staggering 3.0 degrees C above normal.
3 degrees, wow. So that warmth is basically the fuel source.
Precisely. That heat just turbocharges the whole system. It dramatically enhances evaporation off the sea surface. And, there's the physics, the Clausius-Clapeyron relation tells us, for every 1 degree C warmer the air is, it can hold about 7% more moisture.
7% more, okay.
So with oceans this warm, the air mass getting pulled into Europe is just carrying significantly more water vapor than it normally would. In fact, those mild temperatures people might see forecast, Paris or London may be hitting 15 degrees C. That feels nice, but it's actually a direct amplifier of the flood risk.
How so?
Because that warmth means the air can hold and then deliver a much bigger payload of rain when it finally releases it.
So the mild temperatures are actually making things substantially worse in terms of flood potential. Okay, so where's this bigger payload going to hit hardest? Which parts of Europe are highest risk?
We need to watch two distinct kinds of zones, really. First, you've got the orographic areas. These are basically the south and west facing slopes of the big mountain ranges. Think the Alps, Pyrenees, Apennines.
Right, where the air is forced upward.
Exactly. That forces the moisture out as heavy, prolonged rain. And crucially, because it's so mild, it's falling as rain, not snow, even at some elevation. That means maximum immediate runoff into major rivers like the Rhine, the Danube, the Po, the Rhone.
Okay, that's one type of risk. What about coastal areas? So say for someone listening on the Italian coast near Genoa, is there a risk different from someone maybe in the Alpine foothills?
Completely different, yes. The second zone is the Mediterranean coastal basin. Here, the risk shifts. It's more about dangerous, rapid onset flash flooding. These are driven by intense convective storms, thunderstorms, basically feeding directly off that exceptionally warm sea surface. They can be very localized, but incredibly destructive.
And didn't Storm Benjamin already leave the ground pretty wet?
Yes, that's a critical aggravating factor. The ground across much of Western Europe is already saturated, so its capacity to absorb more rain is drastically reduced. It'll run off much faster.
Which means we absolutely need to rely on the monitoring tools we have, things like Meteoalarm and the Copernicus CMSS European Flood Awareness System, EFES, right? CMSS being the Copernicus Emergency Management Service, gives you that real-time picture.
Absolutely vital. What we're really seeing here is it's a potent combination. You've got this dynamically locked-in atmospheric pattern happening at the exact same time as this powerful regional marine heat wave. It kind of represents a new flavor of intense autumn rainfall risk.
And, this convergence, it really underscores a crucial thought for you listening to this. This event highlights just how urgently we need to incorporate these thermodynamic indicators like huge SST anomalies into our risk modeling. Think about it. If our historical flood data, our understanding of frequency, doesn't account for oceans being, say, 3 degrees warmer than they used to be, well, how reliable are our long-term risk assessments, really? Especially in this new, more volatile climate signal we're seeing, it certainly raises an important question.